time for Nerdgasm.
Hey, what's up, Nerdgasm fans? Jerry here, aka Barnacules. Now, you guys have been blowing up my email box, my Twitter, Facebook, Instagram. Hell, you've even been leaving tons of comments on completely unrelated YouTube videos, some of which I didn't even create, asking me, where is Codegasm? Well, guys, if you're watching this episode, you have your answer. Now, I'd like to apologize for my voice. It's really raspy and nasally, and this is because last weekend I attended a huge LAN party in Portland, Oregon called PDX LAN, and I had a blast, but I yelled and screamed until I couldn't yell and scream anymore, and I wore out my damn vocal cords again. And if that's not bad enough, just yesterday I contracted some kind of a sinus infection, so now I'm like nasally and got screwed up vocal cords. But hey, look on the bright side. Makes my voice all raspy and sexy, so maybe that'll help drive up that female demographic.
Ladies.
Now, also, guys, if this is your first episode of Codegasm that you've watched, I strongly urge you to slam on the brakes and go back and watch the very first episode of Codegasm, which I've provided a link to you in the video description. Now, that first episode is going to show you how to download Visual Studio and get it all set up and caught up so that you can follow along in all of the other episodes. This is pretty key and important. Also, if you have a question, make sure you check the video description for an answer, because the most commonly asked questions, I usually provide answers down at the bottom of the video description. I'll also include links to things like the project source code and the binaries, because I know a lot of you guys just want to use these applications and not actually have to compile them, and that's totally cool. Also, if you guys are interested in helping out the channel, I have a donation link down below, and I even have a t-shirt shop now. It's shop.barnerd.com. Go check it out. Every one of these little things helps the channel and helps me keep on improving and moving forward, and I appreciate it. All right, so for today's Codegasm project, I'm actually going to solve a problem that I just recently ran into. If you guys have been following my videos on my channel, you know recently a company called Puget Systems just built a new computer for my nerd cave. It's actually, we called it William, and if you guys want to know why the system's called William, I also have a link to that video down in the description where they built the system. But the problem is the system is built in a fractal design R4 XL case. Now, the problem with the R4 XL case is it doesn't have a hard drive LED. For some reason, they left it off of that model, probably to make it more sleek and streamlined. But I like to know when there's hard drive activity going on in all of my computers. Well, it's a big problem with this computer in specific because it's all SSD storage, which is solid state. Everything's solid state. There's no more clickety click, 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 click like you'd get from a physical moving hard drive. So now I don't have an LED and I don't have any sound indicator to tell me that there's hard drive IO going on. So I decided to take it upon myself in this episode of Codegasm and create a program called Hard Drive LED. And this program is going to basically sit in the task tray of the computer, because a lot of you guys requested that I show you how to make an app that has a task tray icon. And this icon is basically going to blink and mimic a hard drive activity light when there's IO going on any of the drives in the system. So it should emulate roughly what would be happening on the front of the case if the hard drive was being accessed. So guys, let's jump right into this. It's time to get nerdy. All right, guys, jumping right into this project, I just want to tell you about a couple of changes I made. First and foremost, I increased the DPI to maximum in Windows. So as you can see, my mouse cursor is legitimately huge. It's not a small mouse cursor, and you can see the text on everything is actually really big, and the icons themselves are really big. I did this because a lot of people complained in previous episodes that they had to run at full screen at 1080p to see what I'm doing. I'm hoping that you will now be able to follow along at lower resolutions and be able to read the text because of the higher DPI scaling. But be warned, Windows is notorious for horrible DPI scaling, so we may run into some artifacts and issues along the way, but I think it's better off if you guys can see what I'm doing. Also, I have the control key bound to a little indicator to draw your attention so you know what's going on. Now, guys, this project that we're creating, I created two icons up here. You can see one's called HDD Busy, and the other one's called HDD Idle. Now, these two icons right here are ultimately going to go down in the task tray down here, and the red icon is going to indicate hard drive activity, whereas the transparent icon is going to indicate lack of activity and or idle. So for now, I'm just leaving those two icons on the desktop. Now we're going to do this program in a way that these icons can be replaced with anything that you want. So when you download the program or you create the program yourself, you don't have to recompile it to change the icons. You just put new icons with the same name in the folder and it'll just work. Also, another change that I made is I'm trying to start with more simple lessons. In the past lessons, we've gone 30 to 60 minutes, and some of you guys really like the lengthy videos, but a lot of people just had a hard time hanging on for such a long ride. So I'm going to try to get these videos down to about 20 minutes. minutes, give or take. We'll see how well we do on this one. Who knows? But the whole idea being here is I want this to be kind of short and precise lessons that we can build on. This first application is going to be fully functional at the end of this episode, but we're going to add more features to it as time go on if you guys want me to. If you guys want me to move on to a different project and the majority want, I will. But ultimately, I like to create applications that are useful to me because it makes me more passionate about building them, and I think I convey the lesson a lot better. All right, well, let's open up Visual Studio. Right here, I have Visual Studio Express 2013. Now, this is a free download. If you guys watch that first Codegasm video, it'll tell you where to get it. And we're going to start off by creating a new project. You can either do it by clicking the shortcut here, or you can just go to File and New Project. Now, when you open up the new project, you can create all kinds of different projects. You've got the WPF application, the Windows Form application, console application, which is like typing from the command line and text only, or you can create like an empty project, which we're not going to do in this one. Now, for this project, we're going to use a Windows Form application. So even though we're not displaying a Windows Form in this application, we need to start as a Windows Form application so that we don't have a console window involved. So let's go ahead and open up the Windows Form application here. We're going to give it a name. We're just going to call it HDD LED. Hard drive LED. I think that's good enough. We're going to tell it to create a directory for the solution right here. You don't have to do this, but it just makes it neater because it keeps the solution file out of the main directory, and it's just a little cleaner. So we're going to go ahead and click OK. And now Visual Studio is going to build our template project. It's going to create all the pseudocode and everything to make a fully built application right out of the gate that does nothing. So literally right now, if I push F5 or I go up to debug and I go to start debugging, you're going to see the application is going to run. And here you have it. It's literally just this little window with some buttons on it, and it does nothing. You click on it. If you click X, it closes. Now, what we're going to do here is we're going to open up the source code for this form. So if I come over here and right-click on form1.cs and I say View Code, it takes me to the code behind, which is the source code that's actually running behind that visual representation. Now, we did play around with form apps a little bit with the web browser Codegasm. So you guys, if you're not up to speed with this, just go watch the web browser thing. You're going to see how the forms work because we use one there. So in this particular environment, what we want to do is we don't want the window. The window, we want to put stuff down here in the notification taskbar. We don't want a window in our way. So we want this window hidden. And the way that you do that is you access the form1 variable, which in this instance is going to be this. You type this, and we're just going to say window state equals window state minimized. Because when we want the application to start, we want it to be minimized because we don't want anything visible. And then we're going to do show in taskbar equals false. Now what this is going to do when I run the application, I'll show you right now. If I hit F5, you see there's no window. It's invisible. The application is running right now. It says ready. If I come up to debug and I say break, break all, it's going to take me to the line. You can see the program is actually still running. So I'm going to go ahead and continue the program, debug continue, and then I stop the program, stop debugging. Now the application's dead. You notice we didn't see a form. And all we had to do was add these 2 lines of code. So now we've hidden that window because we're not going to do anything with that window, at least not for this version of the program. All we care about is the task tray down below. All right, guys, so we have to add a couple of references. So if you come over to the references, you right click, say add reference. We have to add the system.management namespace and the management instrumentation namespace. Now, these are the namespaces that house something called WMI. And WMI is the Windows Management Instrumentation that allows you to basically gather data from the system, which in this case, we're going to use it for getting hard drive telemetry. So you need to make sure that those are added to the solution. We also want to put some using directives up here. So we're just going to do system.management. And we're going to do using system.management.instrumentation. So we're going to add those 2 namespaces. Now, we're also going to need the specialized collections namespace. Let's see, it's system.collections.specialized. Now, this is actually because we need one of the objects out of there, which will become apparent here in a little while. So now down here, all we have our code when the program runs, the form runs, and then once the form's initialized, it hides itself. That's all that's happening right now. So let's go ahead and add some comments. We're just going to do 2 forward slashes and say, hide the form, because we don't need it. This is a notification tray application. Okay, just going to leave a little comment there to remind myself. And also, if you guys want, you can use the region space just to make stuff more compact, like form stuff. If you just put a region there and down here you do end region, you can now collapse that whole section and all of the functions inside of it. It's just a code beautification thing. It doesn't impact the final project at all. Okay, so now that the program doesn't show anything, we need a notification icon down there so that we have some visual representation of our project. So the first thing we're gonna do is we're gonna create a global. Now remember, when I create a global, it's inside of the class, not inside of the function. And anything inside of the class can be accessed from any of the functions inside of it. There are some exceptions to that rule, depending on whether it's static or instantiated object. But for the most part, just remember, if you create something globally, it's accessible within that scope. So anything between this guy right here and that guy down there should be able to access the variables that we create here. So the first variable I'm going to create is a notify icon variable. And we're just going to call this HDD LED icon. That's it. Now down below, we're going to create a couple of icons themselves. So we'll do icon active icon, and we'll do icon idle icon. Now these are going to be storage for the physical icon images that get swapped back and forth depending on what's going on. And then last but not least, we're going to need a thread, because we need a thread that's constantly running in the background and pulling for this information off the hard drive. So let's go ahead, and for that we have to add another namespace. So just add using system.threading. And now we have access to the thread object. And we'll just call this HDD LED worker. Or actually here, we'll do lowercase, HDD LED worker. That's it. So now we have a notify icon that'll sit in the tray, two different icons that can load in and out of it, and we have a thread that can do the work. So the very first thing that I want to do is I want that notification icon populated. So we're going to go back to the desktop, and we're going to grab our two little images here. These are ICO files that I created. Now, if you guys want to create your own icons from bitmaps or PNGs, I have a link down in the video description to an application. It's made, let's see, who makes it? Telegraphics.com.au creates an ICO format plugin for Photoshop that lets you basically save as ICO format in Photoshop. And that's what I use to create these. So I'm going to copy these two icons right here, and we want to put them into the project folder. So we're going to go to Documents. We're going to go to Visual Studio 2013, Projects, HDD LED. So now this is the main folder, and then here's the project folder. And I'm just going to dump them in here. Just go ahead and paste them. And now that they're in that folder, I'm going to go back to Visual Studio and right-click on my solution down here. Actually, I should say the project. It's the project inside of the solution. And I'm going to say Add Existing Item. And then under Existing Item, I'm just going to put a wildcard so I can see everything. And I want to add both of those, my icons. Now, a cool thing with Visual Studio is when you add like icons and things like that to the project, you can set a build action. So if you come down here in the properties window, you come down here and see where it says copy to output directory. We're going to change that to true, so copy always. And then we're going to go to hard drive idle, and we're also going to change that to copy always. What this is going to do is when I compile the application and it puts that compiled application in a folder, like a fresh folder, it'll copy those icons along with it so that I can now load those icons from the binary's root directory, and or I should say relative path. And the reason you want to do that is to avoid having to pull the icons from like a static location, and it's easier to package because now you can give somebody the binary, give them the icons, they put them all into one folder, and it just works. All right, so now we need to load our icons. So what we're going to do is we're going to take active icon. That's our first one. We're going to say equals new active icon. That'll create an instance of it, or sorry, new icon. And that'll create a new instance of it, and I can pass it a file name. Well, since now it's the current directory, I can literally just do hdd busy.ico, and that'll load the busy icon. I can copy that whole line, come down here. Oh, here, hold on. Active icon. There we go. And then down here, we're going to have idle icon equals hard drive idle.ico. Now, what that's going to do is load the icons from these folders. So I'm going to go ahead and run my program really quick just to make sure it works. You can see right now, nothing crashed. There was no bug reported. So it was able to successfully load those icons. So now what I'm going to do is I'm going to take my notify icon right here, the HDD LED icon, and I'm going to say equals a new notify icon. And then down here, I just basically instantiate it. Boom, I just created a notify icon. That's it. And then I'm going to say HDD LED icon dot icon equals idle icon. So now that's going to set the default icon for that notify icon to the idled icon. And then we're going to display it. We're going to say HDD LED icon visibility equals true. That's all I'm doing right here. So let's go ahead and add a couple of little comments. So I'm going to say load icons from files into objects. That's all I'm doing. Then down here, create notify icon and assign idle icon and show it. That's it. So now if I run this program, what's going to happen, guys? It's going to show a new icon down here in the idle state. So if I hit F5, you can see there it is. right down here. Hopefully you guys can get a good look at that. There is now an idle hard drive icon down here in the tray. So that's pretty easy. We didn't write a lot of code to do that. It doesn't take a lot of code to do stuff like this with C# and the .NET framework. That's why I like it. Managed code is much easier to get results than native code. Native code's a lot longer because you have to manage every little tidbit, but there are trade-offs in performance and things like that. So depending on what your project is, pick a suitable language and libraries and framework to support that. Okay, so at this point in time, we now have an application that has an icon. If I click on that icon, nothing happens. Well, we need a way to kill the program. So we need to interact with that icon. So let's go ahead and stop debugging because it's running right now. Hit stop debug. So now the app isn't running anymore, so we can edit the code. It will not let you edit the code if the application is running. So now let's go ahead and create some menu items. So the first thing we're going to need to do is create a context menu. So a context menu, and we'll just call it context menu, that's fine, equals new context menu. Notice I always use a lowercase at the beginning. This is referred to as camel casing. It's just what I use for your variable name. Normally I use for my variable name because it differentiates it from the capital version, which is the object itself, the definition of the object versus an instance of that object. So it just helps me tell them apart. And honestly, if you had more than one context application in the menu, you'd want to put some other descriptive element on it. But I don't. This is the only context menu thus far. So now we have to add menu items to the context menu. So we're going to do context menu dot menu items dot add new menu item. Now, actually, we want to create the menu item separate so we can control it. So we're going to say create a menu item here. So menu item, and we'll call this quit menu item equals new menu item. Just like so. And then in here, you can see it takes a string and that's the name. So we're just going to put quit. That'll be the text that it displays. So now we have a quit menu item and that's it. And let's go ahead and create one more menu item that just has the name of the program. So we'll just say prog name menu item equals new menu item. And we'll just call it HDD LED V 0.1 beta by Barnacules. And this button will literally do nothing. So now I've created the context and I want to add those two menu items. So we're going to add the program menu item first, just like that. And a lot of this is cut and paste, guys. You can get really fast with cut and paste. Just take the quit menu item and put it in there. So now if I, actually we're missing one step here. Now we've created the menu items. We've added them to the context menu, but we have not added the context menu to the notify icon. So now I have to go to the notify icon, which is this, the HDD LED icon, and say context menu equals lowercase context menu. Now that's going to wire it up. So the order here, guys, just so you know, is create the two menu items, add them to a new context menu, and then add that context menu to that notify icon. It's all about objects linking together. It's called object-oriented programming. It's actually a very, very cool way to program. So now if we run this program, what's going to happen? If we right-click, we should get a menu off that now. So let's go ahead and hit F5. We have our icon right here. If I right-click it, you see we have HDD right here, LED, beta down here in the corner, and a quit. And if I click quit, nothing happens. It's still running. Okay, that's a problem. So let's go ahead and stop that. So now that we know that it's still running, we need a way to kill it. So the way we do that is we got to wire up the click event for the quit menu item. So we just say in here, let's add some comments. We don't want to get too far ahead without creating comments here. So we'll just say create all context menu items and add them to HDD, or add them to notification icons. Tray icon. There we go. Good enough. It's nice to have these little high-level comments for blocks of code like this. And if I was going to use these blocks to create multiple menus items, I would create them as functions. But since I'm only using the code once, I'm just inlining it because there's no need to create a function here if we're only using it once. All right, so now let's wire that up. So we're going to create another comment here, and we're going to say wire up quit button to close application. So now all we're going to do is we're going to take that menu item, the quit menu item, and we're going to say on click like this, type plus equals, and then if I hit tab, it'll automatically create a function. See how I did that? It just automatically creates a function that throws a non-implemented exception. Basically, they do that so that if you forget to implement it, it'll blow the program up in a way that'll tell you, hey, numbnuts, you forgot to implement it. So up here, we have that now. So anything that we run in here is going to happen when we click that quick button. So we have to do a couple of things. When we create the thread, we'll have to shut that down. We haven't created the thread yet. So all we have to do to kill the app right now is say this.close. That's it. Close the application on click of quit button on context menu. Just like that. Now if I run this, F5, if I right click my little icon down here and I go to quit, oh, the program stopped. That's it. But the problem is we didn't clean up our icon. You have to clean up the notification icon. So we're going to say let's grab that notification icon up here. It's like HDD LED icon. We're going to paste this and we're going to say dispose. We're going to dispose of it. So now when I close the application, the little notification icon disappears. So that's clean. You want to make sure everything gets cleaned up when you're writing programs, especially stuff like this where there's threads involved and things get hidden. Because if you don't close stuff down properly, that process could still be running in the background, wreaking havoc on your system, and you wouldn't know unless you open Task Manager. Okay, so at this point, we have a program right now that when run creates a notification icon that has a quit menu item that closes out. So now we have to add the actual functionality to the program. So what we need to do is we need to create a worker thread. And the thread is like another process inside of the process that does things. But it does those things parallel to everything else going on in the program, so it doesn't tie up the UI or cause the program to be not responding. I'm sure you've seen that on a window before. And that's what happens if you're a shitty multi-threaded programmer, is you leave a lot of not respondings laying around. That's why I like the threads. So for the threads, we're going to come down here. We already created our thread placeholder, so now we have to create a thread function. So we're going to come down here to the bottom. Let's just create a new region called threads, just to keep it all nice and neat. And a thread basically is just a simple function that returns a void, and we'll call this hard drive activity thread. That's it. It takes no parameters. So this is it. And if you put 3 slashes, it puts that, little summary that you put on top and say, this is the thread that pulls the hard drive for activity and updates the notification icon. That simple. So now we have this thread down here. Well, we need to launch the thread because the thread's not going to start on its own. So let's go up here. After we're done creating everything and hiding the window, the last thing we're going to do is start worker thread that pulls hard drive activity. And we're just going to say, let's see, where's our little thread? Up here, the hard drive LED worker. Yep, so bring that down here. We're just going to say that equals new thread start. And then in here, we're going to put our function. So we're just going to come down here and just copy and paste, double click, Control C, Control V, paste, hard drive activity thread. And then we're going to start it. We're going to say LED worker start. Now putting those 2 lines of code right there said, I want to create a thread from that function and I want to start it. So now if I run the program, it's going to run this function. And just to prove it, you can just put messagebox.show foo. If I run the program, we get a message box that says foo. But the problem is, as soon as I click OK on that message box, that thread's going to die because it ran to the end. We don't want that to happen. We want this to run forever until we stop it. So what we're going to do is we're going to put something called an infinite loop in here. We're just basically going to say, while true, do everything between these points. Well, it's always going to be true, which means it'll always loop forever. And then we're going to do something called exception handling. We're going to do a try block around this. And then we're going to catch a thread abort exception like this. And what this is going to do is, if for whatever reason I stop this thread from outside, it's going to throw a thread abort exception and I can do some final cleanup and tinker with some things down here. It's just good practice. To be honest, this program would work fine without the try block because we're not doing anything that requires a lot of cleanup. But this is just good practice to do this kind of stuff inside of a try block. So now we're just going to go right here. We'll just say main loop where all the magic happens. I know that's a pretty vague comment. And we're going to get rid of the message box. Now you're going to run into another problem if you run this application. It's basically just going to consume 100% of the CPU because it's going to run that loop as fast as humanly possible. It will consume every cycle on the system. You don't want to do that. So in this case, we want to sleep it. So we're going to do a thread.sleep, and we're going to say we want to pull it 10 times a second. So 100 milliseconds, we're going to sleep between loops, and then that'll free up a lot more CPU. So if I run the app right now, it's now running that loop. So if I open up Performance Manager, and I go over to Performance, you can see we're at like 4% utilization, but let's go look at the processes themselves. Oh, I had to look under the Details tab. So under the Details tab, so let's go find HDD LED right here. And it has a VS host in it because it's running inside of Visual Studio. The debugger adds that. But you can see right now it's consuming nothing. I mean, the process is sitting almost idle because it's just not using anything. Like you can see right here, this is the CPU utilization, 0. That's what we want. We want a 0 CPU utilization. Now, if we go back and we stop the program, just to demonstrate to you guys, I'm going to go ahead and run it without any sleep. Now, if we come over here and look at it, we're consuming 25% of the CPU. The reason being is this CPU in this virtual machine has 4 cores, and a thread consumes an entire core. So that one thread is eating 100% of that one core on that CPU, which is bad. That's not what we want. So we're going to go ahead and kill that. Go ahead and put the thread sleep. So you can see the program is progressing. We're creating a skeleton. And this is how I like to program, is I like to create a template and build in and build in and build in, instead of just writing line for line, top for bottom. It just makes a lot more sense. So now we got our thread. So this is where we're going to do all the hard drive activity pulling. So to do that, we need to talk to WMI. Now, I need to figure out what WMI class to pull the data from. A really cool tool in Windows is if you opened up, you type WBEM test, hit enter, and then under WBEM test, you can click connect, and that connects to the root SimV2 namespace in WMI. Don't worry about the logistics of it. You can go and look it up later, but click enum classes, hit OK, and you get the immediate top level classes. But if you close it and you say enum classes and say recursive, this will show you every single WMI class, and there are a ton of them. Look, it's still enumerating them. So the ones that we're interested in are the perf formatted data WMI classes, because these classes actually return performance information, meaning that they routinely update and change their values. The one we're looking for in particular is perf disk. So if we scroll down here, I think I just passed it. All right, so if we come up here, you have perf disk for logical disk and physical disk. Well, we care about the physical disk IO for this. So I'm going to go ahead and double click it, and it opens up the class. You can click this button that says instances right here, and it shows you all the instances. One for the C drive, because this VM only has one drive. Otherwise, you'd get more instances for like D and E and everything. But it also has one called underscore total, and that's the one that we want because that's the combined data from all of the hard drives in the system. So if I double click this and I scroll down, you see all these little things. It says average disks byte writes per second, reads per second, transfer writes. Here's all the telemetry from that drive. If you refresh it while it's doing a copy operation, those numbers will change. Now, the one we're looking for is disk bytes per second. This one right here. So disk bytes per second, this is the number of bytes that are transacting per second, either read or write. It doesn't matter. They're combined. And this is a nice number because the hard drive LED is very, very binary. Either something's happening with the hard drive or it's idle. That's all we care about. So this is the one we want, is disk bytes per second. So now that we know which class we want, right here, the perf formatted data, or perf disk underscore physical disk, and we know the property name, that's all we need to get the data. Now, guys, I also want to tell you that WBEM test is cool. Poke around in there because you can pull WMI data from any one of those classes in there as long as you're logged in with the right security attributes to read that object. And it's cool because you could easily adapt this program just by changing the WMI class or namespace and changing the object property name. You could be pulling information about the video card. You could be pulling information about the memory. You could be pulling information about the network card. So you could use all of that information to basically make this application better. So let's go ahead and create a management class. That's basically our first WMI class. And we'll call it just drive data class equals new. And then it's going to ask us for the string to the management path. And the management path is just going to be Win32 perf formatted data, perf disk, and then physical disk, like that. Now, I went ahead and created a note on my other screen showing me the name because there's no way in hell I was going to remember that. So you guys can just write it down or just take it from the video. But it's good to keep, I usually keep a notepad open where I keep all my little notes, but unfortunately they're on a completely different screen, so they're not being captured. I apologize for that. I'll find a slick way to do that in the next video. Now, I already made one small little mistake, and that is I'm actually creating the management class inside of the while loop. We don't want to do that. We want to actually create it outside of the while loop because it's going to eat a lot of CPU if I have to keep accessing and recreating that class every single time. You want to make sure that you're doing the minimal amount of work required. So now it's only going to do this once. All right, so now that we have the drive data class object pointed at the right WMI namespace and object, we need to get data from it. So the way that we do that is we create an object called a management object collection. And we'll just call it, drive data class collection equals, and we're not going to create a new version of it, but rather say drive data class, get instances. That's it. Now what that's going to do is this is going to contain a collection of all the instances. So when we were looking at WBEM test, remember how it had the underscore total instance, the C drive instance? It would have an instance for each of the physical drives in the system. So now we've got those instances and we need to iterate through them. So now we're going to use a for each management object, and we'll just call it OBJ in drive data class collection right here. So it's going to go through each of those objects. Each time it pulls that data. Okay, so now we want to check the object to make sure that it's the total object and ignore all the other objects. So we're going to say if obj, and then in brackets name, because that's the name of the object, equals underscore total, like that. Then we want to continue. Otherwise, we just don't want to do anything. So if the object name equals total, then we want to check the object value, which is going to be the name of the object, so object, and then we want to grab a different property, which is disk bytes per sec. Remember that one. So disk bytes per sec, and we want to compare it to something. Now, if we look at that object, it returns an int64, and it tells you that if you go into the WBEM test. So again, here's the instances that I showed you earlier inside of WBEM test total. So that's the one we're looking at. So now you can see all of the property names over here on the side. So, and that's where we get that value, and it tells you what it is. Like for instance, disk read bytes per sec is a uint64. So that we have to note that because the data that it's returning isn't a standard int, it's a 64-bit int. So we're gonna, and it's an unsigned 64-bit int. So we have to convert it. We have to say convert to uint64, and then we want that disk bytes per second. And all we want to do is we want to check it. We want to say if once we convert that, it's greater than 0, do this, else. If it's not greater than 0, so basically it is 0. So here, show idle icon, and then up here, show busy icon. So the way that it's going to work is it's going to query WMI each time through this loop. Every 100 milliseconds, it's going to say, get me the new values. Then it's going to look through those objects to find the one that's a total object, underscore total instance. Sorry, I keep calling it object, the instance. Then it's going to convert the disk bytes per second property of that instance to an int64 because WBEM test told us that the data coming out of it is an unsigned 64-bit integer, which is a really freaking huge integer. And we're going to check it to see if it's greater than 0. Because if it's greater than 0, that means that some bytes are being transacted, read or write, and we want to show a busy icon. And then, of course, at the end, we want to sleep for a 1/10 of a millisecond. So sleep for, 1/10 of millisecond. And you can change that to whatever you want depending on how you want to tune the app. If you don't need your icon to be super responsive, you could do it once every second or every 5 seconds, and it's going to drastically improve the performance of the app. But honestly, these performance counters are designed to be hit rapidly, so it's not a huge performance impact for you to hit it 10 times a second. So let's add a couple of comments just to clean things up. We're going to say connect to the drive performance instance, and then we're going to say only process the total instance and ignore all the individual instances. So come down here, and now the program, as it sits right now, the skeleton is ready. Nothing's going to work yet because now we have to change the icons. So that's where this comes in. We have to go find our icon now. Up here at the top, so you have active icon and idle icon, and then HDD LED worker. Sorry, that's the thread. HDD LED icon is the notify icon object. So we're going to come down here, inside here, and we say we want to show the busy icon. So we just change the icon. That's all we're doing. We're just changing the icon to equal, let's see, icon, where is it? HDD LED icon, active icon. So that's our active icon. And then we're going to come down here and show the idle icon. So LED icon equals idle icon. Like that. That's all we're doing. And I should probably put the comments above so it makes sense. Lots of cut and pasting, man. Control X for cut and Control V for paste. So now we should have a functional application. What's going to happen is the program's going to start. It's going to create the notify icon. It's going to start pulling WMI for hard drive activity, and then it's going to change the icon to the red icon when hard drive activity is detected. So we're going to go ahead and hit F5 and run it. You can see we have our little icon down here in the corner. See it right there? So now we want that icon to turn red. We need some drive activity. So let's go ahead and simulate that drive activity. Let's just go to the Windows folder. Xcopy SEVDF, which means everything from this folder to the temp drive. Okay, everything. Houston, we have a problem. Notice it's not updating. That's a problem. So now we have to go debug the application and figure out what the hell's going on. Now, the way that you debug a program generally is you set breakpoints. So you click on the line, hit F9, and it'll put a little dot next to it. And you see right here, the program's still running, so it stopped. The program stopped here. And you can use F10 and F11 to walk through the code. So I'm going to use F10, which is just step over. It means go to the next line. So we connected, we got the instances. So if you hover the mouse over, you can even see the instances. It says there's 2 instances, and one of those instances is total and the other one is not. So it's going to walk into those instances. I'm hitting F10, walking it along, and it's going to check to see if the name of that object's underscore total. No, it wasn't. It jumped out. It wasn't total. It's going through again. It's going to search again. Oh, and we didn't get a match. What does that tell us? That tells us the total is the wrong name. So physical disk dot name equals underscore capital T lowercase o TAL. So if we go up here, TOTAL, that looks correct to me. But there is a bug here, and that is we're comparing the object name to total. What we have to do is actually put .toString. Now what that's going to do on this object is toString is going to output the value of that object, not the name of that object. So let's go ahead and run it again. So we're going to stop it, debug, start debugging. And now we have a new icon down here in the tray. So let's see if it works now. So I hit F10. Okay, it's iterating through the objects. F10, F10. Now we're at the check. Let's see if it matches. Oh, it stepped in. See the little yellow line? It didn't jump over all that code. It's running through it now. So now it's going to check the bytes per second. They were 0. So then it changes the icon to idle icon. Okay, so the program is now working correctly. So I'm going to stop it. Let's go ahead and remove the breakpoint. To remove it, you just click the little red dot, and we're going to run the program again. Now we have an icon in the task tray. See how it's turning red? It's blinking red right there. So if we come over here, we're going to open up a command window. I'm going to go into the Windows folder, %window, xcopy everything out of the Windows folder to the temp drive. We should see that icon stay solid red. Okay, you guys watching this little icon down here? Okay, I'm going to hit enter. And now you guys can see while the copy's happening, that icon is solid red because it's always detecting that bytes are transacting per second. So, and as soon as I stop the copy, so I'm going to Control C it. Now we're back to idle. And you see the intermittent red flash, and that's because stuff's going on in the background with the hard drives. But you can see that every once in a while there's a little blink. So it lets me know that things in the background and programs are accessing the hard drive. But you can see it works. So if I click that, I'm going to start a copy operation again. It's solid red. So now I have a functioning hard drive LED. Now, if I right-click on this, I get the name of the program and quit. If I click quit, look what happens. It blows up. Why do you think it broke? Object reference not set to an instance of an object. So if we click break, the problem is I told it to close the main window when I did that, but I never stopped the thread. You have to stop the thread first. Otherwise, it's going to keep running and try to access the UI, which is no longer there. So you have to make sure that you do things in very specific orders of operation. So what we need to do is let's go to our object. Remember this guy, the quit menu item? So we click quit, it gets rid of the notify icon, and then it closes the main form. Well, what we need to do is stop that thread first. So we're going to take our little thread. What was the name of our worker thread? I already forgot. Hard drive activity thread. Actually, never mind. It's up here. Hard drive LED worker is the name of the thread. Sorry, that's a horrible name, guys. I'll probably rename it before I upload the code. But what I want to do is I want to abort that thread. So I'm going to right click and go abort. And what that's going to do is when I click that quit button, the very first thing it does before it closes anything is it's going to abort this thread, which is going to stop it on whatever line it is. And it's going to drop down in here. So thread was aborted. Now, right now, I don't really have to do anything down here because I didn't really create anything that I needed to dispose. I mean, I guess I could take my drive management object collection down here in the thread and clean it up. Actually, here, I got to move it outside. So let's grab this, move it outside the try block so that I can access it. Because remember, you can only access it within the scope it was created. So now I'm going to come down here, drop it here, and say dispose. So I'm just going to be a good Samaritan. It would have happened automatically, but I'm going to go ahead and dispose of my object there. And now when I run the program, we have our hard drive LED. When I right click and go to quit, notify icon disappears, and notice it didn't crash. That's good. So the program is now functioning properly. Now the cool thing is this entire program didn't take that much code. I mean, look, this is pretty much the entire code. I mean, if you don't count like initialized components and all the code that Visual Studio created for us, this is a very simple application that could be easily adapted. So I'm going to go ahead and make a couple changes. I'm just going to come up here and just call it hard drive LED, just so it looks cooler. V1 V0. Actually, we'll call it 1.0 since now it works, and we'll call it a beta. And by Barnacules. So the program at this point is complete. So we're just going to go through and do a little bit of cleanup. So we got our little region for our threads. We're just going to say hard drive activity threads. There's only one thread, but we may create another thread in the future. So I'm going to collapse that down. And then we're going to come up here, and this is the menu item. So we're going to go ahead and take this, move this whole chunk out of this region. We're going to put in a new region down here called event handlers. Or more specific, context menu event handlers. And then end region. Just keep your code all nice and clean and neat. So now when you're working on big blocks of code, you know exactly where to go. So now you got form stuff. We'll just change this to main form. And then we'll just call it, it's not really the entry point, but we're going to call it the entry point because for all intents and purposes, this is where what we care about happens. Go ahead and collapse that. And then of course, the last thing you have are your global variables. Now, when I'm cleaning up code, you can also do some other cool stuff in Visual Studio that I'll show you as a part of this lesson really quick. If you right click like hard drive LED icon and you go up to refactor, so there's refactor and you go to rename, you can change it to whatever you want and it'll go change every other instance in the program. So like, I didn't like that I called it, HDD LED icon because it's a notify icon. So I want to do hard drive notify icon. So I'm going to say, go ahead and change it. Here's all the places it's going to change it. Click apply. Done. Now I have my icons. I have active icon and idle icon. Well, you notice when I created the icons, I named one of them busy. It was busy icon. If you come over here, see it's HDD busy. So the naming, conflicts. So you kind of don't want that to happen just so that you can stay sane. So I'm going to refactor active icon to busy icon. Done. Now under thread where I have hard drive LED worker, I didn't use the word thread in it. I like to use the word of the variable. Some people don't like that, but I'm going to say HDD worker thread. Or we'll say hard drive info worker thread. Okay, it's going to change it in those places. Apply. So now I've cleaned all that up significantly, and I really like that. Also, I don't like that it's called form 1. That's pretty generic, so we're going to refactor that and call it invisible form because we make it disappear. Done. So now we've cleaned that up. Now I'm going to come over here to my code really quick and do a little cleanup. So we're going to change form1.cs to invisible form, rename it. And then down here where it's program.cs, we're going to rename that to HDDLED.cs. None of these have an impact on the program's performance. It's just a matter of me just trying to keep things clean and together. And guys, there you have it. The program from start to finish. I don't know how long that was. Hopefully it didn't exceed 20 minutes. If it did, oh well. But there we have a functioning end-to-end. If I hold down Control and hit F5, which means run outside of the debugger, I now have a hard drive activity icon that actually works. So I'm going to go ahead and close all this stuff down. You see my little icon down here on the task tray. Okay, here we go. You see the hard drive LED right there is red. I can still access the menu and quit it if I want. And it's always going to be red as long as there's hard drive activity. Now think about how easy it would be to adapt this program to show different icons when your network activity was at 100%. You could easily turn this program into like a DDoS detection tool. Here I'm going to say, I always want this shown down there, so I'm going to copy it down there. But it's really just that simple. And then all you have to do is take this program and put it in your startup folder or your for when your program or your computer logs in and you're done. Now see the activity's done. Now we're back to just the occasional red blink, but for the most part, it's idle. Well, guys, the hard drive LED program is an amazing success. It works flawlessly. I've been using it for a while now. I'm actually really excited that it turned out so good, and it's such a simple program. And I hope you guys look at the code as a good example and foundation for how to use notification icons in your C#.NET applications and how to utilize a thread to update that notification icon. I really, really enjoy making these videos for you guys, but to be honest, the reason I haven't been making a lot of Codegasms lately is because I feel like I've been getting really rusty. And it's because I haven't been working at Microsoft for like, 6 months now. And it's like for 15 years at Microsoft, I had access to the entire technical education resources of Microsoft. Literally, I could learn anything about anything at any time of day, any time of night, didn't matter. And I don't have that anymore when I left Microsoft. But the great thing is I just picked up the perfect sponsor for the channel, and that's lynda.com. Now, guys, you have to check this out. lynda.com/nerdgasm is the link that they gave me to give to you guys that will get you a 10-day free trial, unlimited access to all of their courses. These guys have very, very high production value video courses on how to do programming in just about every language, including C#.net. I took a couple of their courses already, and they were actually really, really well done, and I would recommend them for beginners, people that are just starting out. And there's a couple advanced courses too, if you're already feeling like you got a really, really strong grip on C#.net, or if you want to learn something else like Java or web development and stuff like that. But they don't just stop there. Their education span is like infinite. If you guys want to learn about 3D printing, I get a lot of questions about 3D printing. And to be honest, some of them I don't even have an answer. They have 3D printing courses on lynda.com. They have courses on lynda.com on how to do video editing, how to do photography, like all the way from like using the camera to editing the final product. It's amazing how much is out there. You could spend 2 lifetimes trying to learn everything that's on that site. And I think that after you guys use it for 10 days, you're going to wonder how you ever got along without it. So guys, please take a moment, head over to lynda.com/nerdgasm, check them out. I would love your feedback, good, bad, or otherwise, but I personally am a subscriber for life. These guys are awesome. Just give them a chance. All right, guys. Well, I hope you enjoyed this video. Please leave any questions you have down in the comments or come hit me up on Twitter. I'm at Barnacules. Also, guys, just like I said before, I've got a new shirt shop open. It's shop.burnerd.com. Go check it out. I've got a couple funny t-shirts in there. I'm sure we got one in there that you'll like. And it really helps to support the channel. And guys, I'm really sorry I sound so bad. That ear infection is literally killing me right now. But even though I'm in a lot of pain and it hurts to talk, I'm very, very happy that I made this video, because getting back in front of the compiler again and actually solving one of my problems writing an application, it definitely just rekindles that romance. And I'm back full force now, baby. I'm gonna be making at least 1 or 2 Codegasms a month from here on out. All right, guys. I think we overshot 20 minutes by quite a bit, so maybe we'll try next time. But maybe it wasn't meant to be, and these all just have to be super long videos. But guys, I love each and every one of you. Thank you for all the support and everything that you guys do so that I can do everything that I do. All right, take it easy, guys. Until next time. Hey guys, I hope you enjoyed this video. Please take a moment and subscribe to my channel. It helps me a lot. Also, come over to Twitter. I'm at Barnacules. I'm a real social guy. Also, if you have a couple of minutes, check out some of these many other videos. I made them myself.